outcome 4 is applying modeling techniques to communicate the flow of information around an information system. So we're going to look at the various techniques that we can use to show how information is actually flowing from one point to the other in an information system. That is basically what we are going to focus on in outcome 4. So the first thing that you're going to look at is the diagrams, the diagrams that we use to show or to illustrate how data flows in and in an information system. So we have the data flow diagrams and we have flow charts that we're going to look at. Now, one important thing that we need to understand is that both the data flow diagram and the flow charts, we use them to give a step-by-step description on the path maybe of the path of a process or data. What path does a process follow step by step, and what path does data follow step by step? So all these diagrams are going to simplify our understanding, or are going to make things easy for us to be able to understand the way a process is actually taking place, or the way data is processed within an information system. So the first thing that we need to look at is the flow charts. So when you look at a flow chart, we are basically looking at a diagram that actually breaks down big or complicated processes into some steps that are simply to follow and to understand. Now, we normally denote those steps in using different boxes. Then we are connecting those boxes using arrows. And we connect those boxes using arrows. So normally the flowchart is going to start from the beginning of the process and is going to follow the steps throughout the process until the end. But again, they're going to they might, or in one way or another, show what problems that they may occur in that particular or during that particular process and how to actually deal with them. So when you look at a simple flow chart, now this is a flow chart for software installation. It's a basic and a simple flow chart. I'm sure if you've done installation of any software, then you have followed these steps at one point or the other. So it's something that you can relate to. It's something that you can understand. Okay. So when we look at it, when you look at it, we have the beginning of a process. I mean, the beginning of the installation. Here we have the start button. Then we are showing with an arrow that after starting the software, or maybe running the software, we need to accept or we need to show the agreement, the license agreement. Every user of a software must accept a license agreement. So we need to accept the license agreement. So we need to actually display it to the user. We need to show it to the user. So if the user is going to accept that agreement, then we are going to select the folder into which we are going to install. But if the user is going to if the user is going to is not going to accept the license agreement, then we are ending the process. In other words, we are not going to allow the user to install the software, to use our software, if the user is not accepting the agreement. So that's why we have this arrow. If we accepted, then you choose a folder into which we are going to install. But if we don't, we end the installation. Now realize, if it is accepted here, we choose the folder. Then after choosing the folder where we want to install, we need to look at that folder and see, do we have enough space in that folder? If we have enough space, then we can copy the files. But if we don't have enough space, we can request the user to free some space. And then once we have enough space available, we can continue with copying the file, finish the installation, and we actually finish it there. So we are trying to show for flowcharts, we are basically showing the flow of processes using boxes. So we have these are processes, okay. But when you go to the data flow diagrams, we are going to show how actually data is flowing throughout the system, okay. So if we look at this simple data flow diagram here, we are focusing on how data flows. So we can start from, this is a student administration data flow diagram. So from here we have the student. We have the student here who is going to fill in an enrollment form. After filling the enrollment form, then we have this process to enroll one. Then you can see that the class roles are normally taken to the staff that are actually dealing with the enrollment. Then from the staff, you're going to receive examination papers to the examiner. Then the examiner is going to mark the papers and give grades, and those grades are going to be stored in the student's file. So the student will be able to obtain the academic records that are going to actually determine if the student is going to graduate or not, and that information can go back to the student. So we're just trying to show how data is actually flowing from one part of the other throughout the process using the data flow diagrams. Now, I've done a comparison of the flow chart and the data flow diagram. So you look at the flow chart. First of all, it is going to represent the steps that are supposed to be followed to complete a process, while the data flow is going to show how data is actually flowing from throughout the system. That is the first difference. Now, if you look at the flow chart that I have just shown you, we don't have any input or maybe output to any external source. We don't get input from external source. We don't get output from external source. But if you look at the data flow diagrams, you're going to realize that they are going to show the path of data that is coming in from external sources to internal store, and vice versa. So we have the timing and the sequence of the processes that is actually shown in the flowchart. But if you look at the data flow diagrams, the process of data is normally taking place in a particular order, following some several processes that are going to be followed simultaneously. But this is not actually shown in the data flow diagrams. So the flowchart diagram are going to show how to make a system function, for example, how to enroll or how to install software. But the data flow, they are going to show, they are going to define the functionality of that particular system. Again, we use our flowchart diagram in designing processes, where we use data flow diagrams to describe the path that data is going to follow to complete a given processes. So in flowcharts, we have a different types, and the first type of a flowchart is the system flowchart. We also have the data flowcharts. We have documents flowchart, and we have program flowcharts. When you come to the data flow diagrams, we have two types of data flow diagrams. The first one is physical data flow diagrams, and the second one is logical data flow diagrams. So those are basically the difference. Now, then we need to move to another type of diagram. We call it a context diagram. So a context diagram is normally some kind of a graphic design that we use to clarify what interfaces we have and what are the boundaries of the project, or maybe that particular process. Now, normally the context diagram will not show the process, or it is not going to show the project in its particular context, but then it is going to show the interactions of the projects with other systems and other users. How is that project interacting with other systems, or we can say subsystems, and how is that project actually interacting with other users? Yeah, so when you look at a definition given by Wikipedia, a context diagram is taken to be the highest level view of a system, showing a system as a whole and its inputs and outputs from or to external factors. Okay, so let's just look at an example of a context diagram. So we have the borrower application here, that is going to submit the borrower data. Then we have to get the credit score from here. Then that information is obtained from the credit bureau. So they submit the credit report. They receive the borrower data from the get credit. Then they submit credit report. Then we have credit report that undergoes internal processing. So when you look at a context diagram, it is going to fall into one of two categories. And the first one is it is going to lack formal structure. Okay, we just place an object in its context. We are going to show how that object is going to interact with external entities from a high level. It is normally this particular document that lacks any formal structure is normally produced by those people that they do not have formal training in producing such diagrams. Okay, then they have the second type that is a little bit rigid. We are actually drawing it from rules, specified rules, specified syntax, and we have symbols that are actually going to be used. So if we look at um, the benefits of context diagrams, or why is it important that we use context diagrams? So we need to look at the advantages of context diagrams before we go to the parts of context diagrams. So number one, we use context diagram as an instrument to make sure that we are achieving the thinking processes, and we are also triggering our memory recall of a particular subject that is actually given there, to make sure that we are activating our thinking processes and we are triggering a memory recall. So they help us to remember some context. So they will also reveal anything that is actually omitted from maybe the business plan or the business requirements. You have come up with your business plans, with your business requirements, but when you draw the context diagram, you'll be able to see if there is anything that you have omitted, or there is any error that you actually made in those particular requirements, both the business requirements and if there's any error that you have made, you'll be able to see that particular error. So if you look at the objective of a system context diagram, it is going to focus on attention or on giving an attention on external factors and even events that need to be considered as we are creating a complete system. Now we want to make sure that we are getting maybe feedback from the project stakeholders, so that we can see we can identify any pieces that are actually missing and implement them. So the other thing is we have the context diagram serving to remove ambiguity and making sure that we are defining a project scope. So it makes sure there is discovery, there is confirmation of high-level events that are going to trigger the processes, including both the external entities and the internal entities. Okay. So what are the disadvantages of the context diagrams? The first disadvantage is that the diagrams are not showing the sequence. So because the diagrams are not showing the sequence, if we are working with some business people, they might have some difficult time to follow those diagrams because they don't show the sequence. They're just showing the context and the relationships, but they do not show. They show the context and the interactions, but they don't show any sequence, steps, or flow. Okay, and that is a disadvantage, because the business people might have difficulties following them or understanding them? Okay. Okay. So this the second disadvantage is um, they're going to the diagrams are going to present the data that is flowing in and out of maybe a project, but at a higher level. They don't show what elements, they don't show which elements are actually flowing in and out, and this is going to be somehow a problem, when we are dealing with people that are detail oriented, people that really want to know which type of data flows in here, which type of data flows out of this. So if you're dealing with people that are detail oriented, then you realize they're going to you're going to have a problem. Okay, then we also have another disadvantage, and that is the falling out of favor of the data flow, the data flow. Now, um, because when we look at outside the scope of information systems, we have business people that are not able to relate to the many levels of data flows that we are actually giving in there. People prefer to work with the workflows instead of the data flow. Okay, those are the three disadvantages. So we have the parts of a context diagram, and the main parts of a context diagram. The first one is the process. The first one is the process. We normally represent the process using a rounded rectangle. Okay, let me show you this one. This is what I mean by a rounded rectangle. So whenever we are showing this, a rounded rectangle, then we show a process. We normally show the process number at the top of that, at that of that rounded rectangle. Okay, so we need to make sure that we are showing the process number at the top portion. Okay, now when you look at it here, this one is showing you it is process 1.0, so it is process 1. Okay, and the name is process application. Process 2, the name is get credit, and process 3, the name is send offer or rejection. Then we have the external entity. The external entity is going to be an actor. I talked about an actor, and I said an actor can be a person or maybe an entity that is actually trying to trigger a process or is going to receive any input or rather output from a process. Maybe you're contributing input to a process or receiving output from a process. So it can be an external entity that it can be maybe a data source or a data destination. We are getting data from, or we are sending data to. Okay, so we normally show those external entities using rectangular boxes, as you can see here. So this is the customer, this is the credit agents. We are showing them using rectangular boxes. Then we have the data flows that we normally show them using arrows. Um, and these are actually the connectors. We are using them to connect the processes and the external entities so that we show the data that is actually flowing from which process to which external entity and vice versa. So we have an example of a process diagram like this one here. So we have the source, we have the source. So we have input going to the process, then output to the destination, then input can come from the process at the same time. Okay. Oh, that's great. Now, mm, uh-huh. So I want us to talk about we've talked about data flow diagrams, and how we use them to illustrate information flow between agents. So I'm just going to show you examples on how we can do that with two or more agents. So I just show you a number of things. So I've talked about circles and what they are, the curved lines. No, I mean the rectangular boxes. I've talked about circles and the rectangular boxes. I need to talk about these curved lines. Now, normally we have the curved lines that are going to represent the data that is actually flowing in and out of a process. The curved lines will show the data that is flowing in and out of a process. So if I show you an example here with a curved line, then you'll get a clear understanding. Yeah, you can see now we have this curved line here. Now this shows the flow of data in and out of a process. So so far so good. So talked about the curved lines. I talked about the rectangular boxes. So I have an example here of a reservation system. Okay, a reservation system. Reservation system is a system tunatumia maybe kubook a room, something like that. So you can see now we have the guest. We say these are actors we represent with rectangles. We have the guest, and then we have the information that the guest supplies is the name, the dates, the location, the profile, and that goes to this circle here. To a reserve hotel room is a function. So then the reserve hotel room is going to send the dates, location, and profile to the reservation system that is going to check if that particular room is available. Then it's going to return feedback to the reservation hotel room, and that feedback is going to be sent to the guest to confirm if the room is available. Then all this information is going to be stored in the hotel, probably the database of the hotel. So these are just examples. Was just an example of that diagram. Now we have sequence diagrams also. Now the sequence diagrams are going to show the interactions among classes. So when we talk about interaction among classes, we are talking in terms of how messages are exchanged over time. We normally call the sequence diagrams as event diagrams. We can use those words interchangeably. Event diagrams to mean sequence diagram. So when you want to visualize and maybe validate some various runtime scenarios, then a sequence diagram would be the best option, because it is going to help you to make a prediction of how that particular system is going to behave. And you can also discover some responsibilities maybe. So we have the basic sequence diagram notations, and the first one is the class role or the participants. And the class role is actually going to show an object, and we normally use this symbol to show an object. Okay, this is we use this symbol to show an object. Then we have the activation or maybe execution occurrence. Now these are normally boxes that we use to show the time maybe an object needs to complete a task. What time will that object take to finish a particular task? Okay, so we might have an object might be in executing state, or might be in a waiting state as it is waiting for a reply. And so we can show that using this rectangular, this something looks like a bar. It's a rectangle, yes, but looks like a bar. Then we show the messages using arrows, and those arrows we use them to represent the communication between the objects. So when we are representing asynchronous messages, we use half arrowed, and when we are representing synchronous messages, we're going to use the full arrows. So we have the message types presented below, as you can see. So we have, this is the object, this is the object. In other words, this is now the waiting time. The time it takes to finish a process. Like this message is this object is sending a message. To this object. So when it is sending a message to this object, this is the time it will take to do that. Then it enters into a waiting state here, because it's waiting for the information. Now this object is going to take this long. This is the time it will take to process that message and send a reply back to that object. That's how we show sequence diagrams. We have the object, then we are showing the time that actually each process takes to process messages received and return replies. We also have live lines. We normally show them using dashed lines that are going to show the objects that are actually present over time. So when we show this one, we call this one a live line. So this means this project is available. In other words, it is in a receiving state. Inaweza pokea any message. This object can receive any message. So we call these dotted lines, uh, we call them live lines. We call those live lines. So there are two types of messages that we can receive and we can have in sequence diagrams. And the first one is the synchronous messages, and then we have the asynchronous messages. Now this is the difference. For the synchronous message, is actually a type of a message when you send that message, then before you can actually continue to interact with the system or to continue doing some other things, you must receive a response. You must receive a response before you can continue with any interaction. And we normally you normally draw it using a solid line that has this type of a head, as you can see. Then the asynchronous message is you can send that message and continue to interact with the system before a reply is sent back. That is asynchronous. So we normally show them using this type of arrows. Okay. So this one is asynchronous. This is can use either of these, this one or this one, to show asynchronous. So we have a reply or return messages. We use it with this arrow. A reply or return message, we use it with this arrow, but it's dotted. I want you to see it's dotted. The arrow is dotted. So whenever you see that arrow, it means this is a reply message. Then we have a self message, a message sent to the same object. When an object sends a message to itself, so we are showing it using this arrow. You can see you're showing it using that arrow. Then this is the time and this is the time of reply. You're sending it to the same object. So a self messaging. So we have the create message. We show it. The create message is normally going to use to create a new object. It somehow looks like the return message, but it has dashed lines. It has an open arrow also, as you can see, the open arrowhead. We have an open arrowhead. So that's how we show it. Then delete message, we show the arrow with an X huku mbele. Okay, this one is going to destroy an object. Then found message, you have that arrow, then we have this dot, circle, then we have a black dot inside, showing that a message that was sent maybe from a recipient to a recipient that is not known, from maybe an unknown recipient, is going to be shown with this arrow. So it has the end point to a live line. Then a lost message. So if you send a message to an unknown recipient, you have sent a message, but the object to receive that message is unknown. You're going to show that message with this symbol, that arrow and this. So I have a number of examples of sequence diagrams. Like for example, this one is for shopping cart. Yeah. So make sure you follow these examples. You just try to understand them when you are revising. Try to understand what is happening, because you might be required to draw a diagram. I've given a number of them. This is a logon scenario. I've given a number of these diagrams. That is a logon scenario. So make sure you follow those diagrams and make sure you are able to really understand what is happening.